Problem number 47. Verify Green's theorem for this line integral along the unit circle C, oriented counterclockwise. Okay, so here we go. Oops, that should be going in that direction here. How do we parameterize C? You can parameterize it, of course, with cosine t, sine t, and t runs from 0 to 2 pi. Okay, I guess let's just write down some facts that we are going to need. Our prime of t is going to be negative sine t comma cosine t. What else is there to say here? Okay, well, maybe I should write down, what is Green's theorem going to say? Green's theorem is going to say that the integral over C of xy squared dx plus x dy, if we write this as the integral over C of m dx plus n dy, is going to equal to the double integral over R, where R is the region inside of our curve here, of the partial derivative of n with respect to x minus the partial derivative m with respect to y dA. Okay, so maybe I could start with the right side here. So the double integral over R is going to be of the partial derivative of n with respect to x, it's 1, minus the partial derivative of m with respect to y, and that would be minus 2xy dA. How do we evaluate this integral? We're integrating over the unit circle, the interior of the unit circle here. This is easiest to do in polar coordinates. So the bounds here, theta will be from 0 to 2 pi, r will be from 0 to 1, 1 minus 2 times r cosine theta times r sine theta, and then times r dr d theta. Okay, what do we have here? This is going to equal, let's see here. So theta runs from 0 to 2 pi, r runs from 0 to 1. Let me distribute through that r. We'd have r squared minus 2r squared cosine theta sine theta dr d theta. And that's going to equal, theta runs from 0 to 2 pi, r squared will become r cubed over 3, and then this will become 2r cubed. Sorry, what mistake did I make? That wasn't supposed to be an r squared, that was just supposed to be an r there. So this becomes r squared over 2 minus 2r cubed over 3 cosine theta sine theta, and then plug in r from 0 to 1 d theta. And so r is equal to 0, this will just be 0. So this is just theta from 0 to 2 pi, the integral of 1/2 minus 2/3 cosine theta sine theta d theta. Okay, so let me just kind of write down the final answer at this point. The integral from theta is equal to 0 to 2 pi of 1/2. That constant is just 1/2 times 2 pi. And then this term, when you integrate this, you could do it with substituting in u is equal to your choice of sine theta or cosine theta. You'll end up with 0 here. So the answer is pi. Okay, so we show the answer is pi on the right here? Well, we also need to figure out, calculate the line integral on the left here, and need to make sure that we still get pi. Okay, so let's see, where are we? We have r of t, we have r prime of t. We know, let's do f. So f here is going to be xy squared comma x. Okay, so f of r of t is going to be x is cosine t and y is sine t. So it's cosine t sine squared t, and x is cosine t. And then we also know we're going to need f of r of t dot product r prime of t. So this dot product with this right here. So cosine t times sine squared t times negative sine t is negative cosine t sine cubed t. And then we have cosine t times cosine t is plus cosine squared t. Okay, so then the integral we have to compute then is the integral where t runs from 0 to 2 pi of negative cosine t sine cubed t plus cosine squared t dt. And again, in the interest of time, let me just write down the final answer here. If you integrate this term, you can do it by setting u is equal to sine t and du is equal to cosine t dt. This integral, this part will give you 0. And when you integrate cosine squared t, or t runs from 0 to 2 pi, this will give you 1/2 times 2 pi is pi. So your answer will be 0 plus pi is pi, just like it was before. Okay, so that's 47 with some details skimmed over, but I'm sure you can fill in the remaining details if you want to.